Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I am part of the developer relations organization here at Oracle. And today we're excited to show you via live demos how mixed node clusters enable seamless scaling and tailored workload placement for diverse application requirements. I'd also like to note that we are recording the webinar and you'll receive the replay via the same email that you registered with after the event concludes. If you have any questions, we've enabled the Q&A section of the Zoom and we'll answer throughout the hour as well as leave some time at the end for any remaining open questions. So today's webinar will be presented by Matt McDaniel, Staff Cloud Engineer on the Code Innovate team, and Payal Sharma, Senior Cloud Architect for Oracle Cloud Infrastructure. So without further ado, I will hand it off to Matt to take it away.
All right. Thank you all for showing up. Really appreciate it. We have a very interesting topic today, which, as Tara introduced, we're going to show you how you can optimize workload scheduling using a new feature within OCI Kubernetes engine called mixed node clusters. So the agenda today is I'm going to spend a few minutes giving you an introduction to OKE if you're not familiar with the service. And then we're going to dive straight into the different types of nodes within OKE, and my colleague Payal will go through the differences and the benefits of using certain nodes over the other. And then I'm going to show you a demo of how to use these mixed node clusters. I'm going to show you how you can create a mixed node cluster yourself and an example application which takes advantage of the benefits of using one type of node versus another. And then lastly, I will tell you a little bit about Virtual Code Innovate, which if you've seen me here before, you're definitely familiar with that. So without further ado, let's go ahead and get started. So what is OCI Kubernetes Engine? So Kubernetes Engine is our container orchestration platform. So it is responsible for, well, giving you a managed Kubernetes service. What this allows you to do is it allows you to deploy and manage and scale both GPU and CPU resources for any type of workload. So this can be AI ML workloads, ETL workloads, anything you can think of. Kubernetes is an extremely popular platform for deploying cloud native applications, and it continues to do so today. So, what's the benefit of using a managed Kubernetes service? Well, arguably, the biggest benefit is the managed control and data plane. So in Kubernetes, you have the control plane, which has what I call the brains of Kubernetes. It has the components that are required to make Kubernetes run and function. The data plane is where your applications reside. And we provide a fully managed control plane and provide a lot of quality of life features for the data plane. Ultimately, this leads to greater agility, flexibility, and scalability. So instead of working on, plumbing, which is common with self-hosted Kubernetes projects, that is all managed for you. And ultimately, this allows you to scale greater without worrying about the common pitfalls of scaling. So this does reduce total cost of ownership just due to the fact that you're more focused on running your applications and developing your applications more so than trying to fix, faulty issues within a cluster, which is tedious and doesn't benefit you at the least. Another benefit for OKE is the ability to have massive Kubernetes clusters. So Kubernetes clusters can grow to massive amounts, not just a few nodes, talking thousands of nodes. And that is a benefit for using OKE because it allows you to scale up to that amount. Okay, I'm going to take a step back and talk about how containers work on OCI in general, and then we'll dive a little bit more into Kubernetes itself. But I just want to give you an idea of the landscape of how containers work in OCI. Here, the y-axis is labeled managed by OCI. What this indicates is the degree to which OCI manages the infrastructure and the overall operation of these services. Obviously, when you go higher, means there's greater Oracle management of these services, and if it's lower, then it's more managed by you rather than OCI. On the x-axis, we have control and flexibility, where greater control is to the left. And what this indicates is you have greater control of the underlying hardware. Going to the right, you have greater agility. So you have less control of the underlying hardware and the functioning of the service, but it allows you to develop quicker, scale quicker, and so on. So if we look at the individual boxes here on the left side, we have do-it-yourself Kubernetes. This is if you were to deploy Kubernetes on compute using something like kubeadm, kubespray, or cluster API, where yes, it does bootstrap all of the Kubernetes components for you on compute, but ultimately you have to manage that compute. You have to manage the cluster. If something goes wrong with the cluster, you have to debug it, and it's not necessarily self-healing. That being said, you have the most amount of control here, so greater customization of the underlying components. I'm going to skip over managed Kubernetes for a second and just go straight to serverless here. On the right-hand side, we have serverless, and you can see it's a very tall box, which indicates that it's mostly managed by OCI. You have limited capability to actually customize the underlying hardware that uh, these services run on, but ultimately that gives you the greatest agility. It's very easy to develop and deploy your applications on these services. Now let's go to managed Kubernetes, and you'll see that we actually have three boxes within this managed Kubernetes, and this is the main focus of this presentation. We have OKE with self-managed nodes, which is essentially we provide compute, or you provide a compute rather, and we install the Kubernetes software on it, but you ultimately have control of the box that it's running on. So you can spin up a VM, do any sort of customization you want on it. And the problem with that is OKE doesn't necessarily mess with that machine. It's your machine. You can do with it as you please. Then we go to OK with managed nodes. OK with managed nodes indicates that um, we bootstrap all of the Kubernetes components for you, so you don't have to. Very easy to work with. There are self-healing functionality there. There's functionality that allows you to more easily manage these nodes. But ultimately, those are VMs with Kubernetes components running on it. This is the most common node type we see with users running OK. However, we do have a serverless option with Kubernetes, which is OK with virtual nodes. So virtual nodes, Pyle will go into more detail here, but this abstracts a lot of the infrastructure from you. So you have greater agility, but less control here. Okay, so the control plane for Kubernetes consists of a few components: the API server, etcd, the scheduler, the controller manager, and the cloud controller manager. These are all managed by Oracle. So you do not need to install your own cloud controller manager, your own kube controller manager, or anything. You don't need to update them. You don't need to make sure they're running um, at all because Oracle manages that. We manage the scaling for it, any storage requirements for it, and resource requirements are all done by Oracle. For the data plane, it's a little bit different because on the left-hand side, we can see the Oracle tenancy is all the control plane nodes. Oracle manages it. You do not need to worry about this. We do send you logs in case you think there might be an issue with a control plane component, but ultimately that's all managed by Oracle. On the right-hand side, this is the main focus of this slide, where this is the data plane. The data plane consists of your nodes, your load balancers, your compute, anything that interacts with the Kubernetes cluster is all being run on the data plane, which runs within your tenancy. So in OCI's or OKE's case, we have a lot of different options when it comes to how you manage your data plane. And Payal will go into more detail here in a bit. But we can see in this node subnet here, we have node pools. These node pools can consist of different types of CPUs. They can be x86, they can be ARM, they can be GPUs even. If you want to run GPUs, they can be bare metal, optimized shapes, and so on. So this is the main focus of the data plane is the different types of nodes you can use in Kubernetes because different Kubernetes workloads require different types of nodes. So now I'm going to pass it off to Payal, who is going to go into more detail on the different types of nodes in OKE and what the benefits are. Payal, I'll pass it off to you.
Thank you, Matt. Good morning, everyone. Thanks for joining. Today, I'll be covering OK node types and how each helps you manage workloads efficiently. Let's deep dive in. So, as you can see, OK offers three main node types: self-managed nodes, managed nodes, and virtual nodes. All three benefit from a fully managed control plane, meaning Oracle handles the Kubernetes API server and core cluster operations. However, the difference lies in how much control and operational responsibility you as a customer take on for the worker nodes. Think of it as like cars. Self-managed nodes are like manual cars where you have full control, and you handle everything yourself, right? Managed nodes are like more like automatic SUVs, which are reliable, but someone else helps with the maintenance. Virtual nodes, however, they are like automatic self-driving cars where you sit back and enjoy the ride. Let's look at them one by one in detail. Next slide, please, Matthew. Self-managed nodes, they are called bring your own nodes. This gives you um, maximum control. You create and manage your worker nodes yourself by choosing any compute shape, uh, including the specialized setups like RDMA enabled bare metal for HPC, GPU instances for AI ML, or confidential computing for highly secure applications. While the control plane remains managed by Oracle, you handle Kubernetes upgrades, OS patching, scaling, and troubleshooting by yourself. Managed nodes, however, they offer a balance between agility and control. The control plane is managed by Oracle, but the data plane follows a shared responsibility model. You choose the compute instance, shape, or OS and manage their life cycle. However, Oracle handles the node pool scaling and updates. Virtual nodes, they are serverless Kubernetes experience. Oracle handles the worker node infrastructure entirely, including scaling, upgrading, and troubleshooting. So you only manage your applications via Kubernetes API. This simplifies operations, resource utilization, and also lowers down your total cost of ownership. You pay per pod, so you are only billed for what you actually use. Next slide, please. Um, so For managed nodes, you don't have to worry about compatibility. You can choose from wide range of compute options we have available on OK, including ARM, AMD, GPU, bare metal, or even customized images or startup scripts. They are good fit for most workloads, both stateful, stateless, because they can scale automatically and make upgrades easier with node cycling and run in your tenancy with host level access. They are ideal for, can you, next slide, please. They are ideal for cloud scale e-commerce applications, CI/CD pipelines, data processing, ETL, and security operations. They are great if you want, more control with specific compute shapes or, host level configuration while still simplifying operations. Next slide. Virtual nodes, they give you serverless Kubernetes experience, as we have talked earlier as well, where you don't have to manage any worker node at all. Oracle takes care of everything, including patching, OS patching, uh, scaling of infrastructure, troubleshooting, or any upgrades. So you only focus on your applications. You pay only for the ports that you are utilizing, and you get strong security through pod level isolation and networking controls. Virtual nodes are best for stateless apps with sudden spikes in traffic, for example. stateful batch workflows with Spark jobs, multi-tenant clusters, etc. They are flexible, secure, and let you focus purely on your applications. Self-managed nodes. With self-managed nodes, you can bring your own compute instances or instance pools and use them as worker nodes on OK. This gives you complete flexibility to use your shapes and configurations that aren't available through OK API. These nodes run in your tenancy with full host level access. And interesting thing is Kubernetes labels are automatically applied uh, for port scheduling, and metrics and logs are sent to OCI monitoring and logging. These are best for, they basically support all kind of workloads, but they are ideal for cutting edge compute configurations, AI, ML, HPC workloads, or any highly secure workloads. They're basically anything can you can think of they are used for. And the good news is OK allows heterogeneous node pools now. So you can mix different node types within a single cluster. And Matthew is going to show you in a demo how this is possible. Over to you, Matthew, for the demo.
All right, thank you very much. So before I go into the demo, I'll just talk a little bit about why this matters and why we're talking about it. So as Payal just said, we now allow heterogeneous node pools. What really we mean by that is you can mix and match what type of nodes you want in your Kubernetes cluster. If you're a Kubernetes user in OCI, you'll know that prior to this release, you could only use either managed nodes or virtual nodes in a cluster. And with the exception of self-managed nodes, that's a little bit of an outlier. But before you could only use one or the other. So what I'm going to show you today is a demo in which we utilize both in a single cluster and how you can most effectively utilize it for your own application. So in this case, I do have a demo here, and I have a diagram to show after this, but just to give you a rundown of what we're doing, it's a basic travel agent chatbot, and I'm using Ollama for CPU inferencing. The purpose of this is I want to demonstrate using virtual nodes, so the serverless nodes, no infrastructure needed, with the managed nodes, where there is some infrastructure there that I do want access to for certain reasons. In this application, I have the front end deployed on virtual nodes, and the back end is deployed on the managed nodes. And then lastly, I want to scale this application, namely the front end, using a horizontal pod autoscaler. So this is what the application looks like. It's a simple UI using Streamlit, which tells me to speak with an AI. When I ask it a question, it goes to my Ollama LLM. I'm using Orca in Ollama to ask it questions, and then it returns the response to me. And then the result, the history, is stored within an Oracle database running in Kubernetes. So a more technical diagram for this looks like this. So on the left-hand side, we have virtual nodes. I have my travel chatbot UI, the Streamlit application, running on this virtual node, and it is doing two things. It is first prompting Ollama questions that I ask the UI, and Ollama returns the result. And it also stores the history, it stores what I'm asking Ollama in an Oracle database. This database is using block storage, using a persistent volume to store the results that I'm sending it. Now, and this is actually the reason we have the two separate nodes here, because these nodes are here to excel in their niche. So in virtual nodes, I want this chatbot UI to scale. I don't want to worry about using um, a cluster autoscaler to scale managed nodes. I want to use virtual nodes because I can scale to a greater amount of pods using that. I'm using the managed node here because I have a database, and this database requires persistent storage. So one of the differences between virtual nodes and managed nodes is that in managed nodes, you can use persistent volumes. You can attach those nodes to OCI storage and, well, save whatever information you need. Virtual nodes, you cannot do that yet. So here I'm using each node to their advantage. In the past, before this release, you would have had to use two managed nodes here. And it's not the end of the world to use two managed nodes. People do it all the time. Uh, but there are some pitfalls when it comes to implementing something like the cluster autoscaler for these nodes. Um, Scaling is quicker with these virtual nodes. It's optimal for bursty applications that need to scale quickly. Okay, so I'll stop talking and go into the demo itself. Actually, before I do that, sorry, let me talk about the other aspects of this diagram that I just forgot to mention. Part of this demo, I also have the metric server running on both my virtual node and my managed node. This is to export metrics about the pods to Prometheus. So I'm going to show you how you can monitor applications running on virtual nodes and managed nodes. I also am using the node exporter on the managed node so that I can export node level metrics to Prometheus. Notice in the virtual node, I do not have a node exporter running on this because there's no reason for me to, because these are serverless machines. You do not need to worry about the management of the underlying uh, infrastructure, just the metrics that your pods are sending. Lastly, the last thing I'll mention here is I am using the Oracle database operator. If you haven't used this, I highly recommend it if you are using Kubernetes applications that interface with Oracle database. It is a great it is a great tool to quickly spin up new Oracle databases, whether that's in Kubernetes or outside. So you can use this to spin up autonomous databases or DBCS, for instance. So it's not just for databases running Kubernetes, it's also for managed databases as well. Okay, now let's go into the demo. Okay, so the first thing I'll show you is how to create the virtual nodes in your Kubernetes cluster. So what I'm going to do is I'm going to search OKE and go to my Kubernetes clusters. Okay, so here's my Kubernetes cluster. I'm calling it OKE cluster. It has two node pools here, and it's within that VCN. So I'm clicking into it, and I'll show you more information. So here's my OKE cluster. It has two node pools here. Let me click into the node pools. Okay, so I have two node pools here. You'll see one of them is called virtual pool and the other is called managed pool. So as you can probably guess, the virtual pool is of node type virtual and the managed pool is of type managed. So that just indicates what type of node it is, of course. Um, Now, how do you create a virtual pool? So here, you click into here, you give the node pool a name, and then there are two node types. You see managed and virtual. So in the past, you could only choose either or, depending on what type of cluster you set up. But now you can select both. So in managed, you can set it up the same way you always have. You can select the availability domain of your Kubernetes nodes, what type of shapes there are, what image you're using, how many nodes are in the node pool, boot volume, pod communication, things like this that you've always been able to work with. Now we can select virtual here. So it says here in the text, the Kubernetes worker nodes are virtual. The resources to execute your Kubernetes pods are provisioned dynamically as needed, and you are just charged for the resources you're using. So similarly to managed nodes, you can set up the placement configuration, what availability domain you want to use, how many virtual nodes you want to use in this pool, what type of shape should the pods take. So we support ARM and x86 for virtual nodes at the moment. And then pod communication, what subnet the pods should be placed in. Once you set this up, you just click add and it spins up the virtual nodes. So I already set up a couple of nodes here, just so it takes a little bit for them to spin up. The difference between these two is if I click in the virtual pool, I actually can't see the nodes because, well, they're virtual. However, I can see the nodes within the managed pool. So if I were to click into managed pool here, I can go in and actually check the compute that the Kubernetes nodes uh, are using. All right. So once the node pool is loaded, you can click on nodes and it'll show you the list of managed nodes in this pool. You cannot see this with the virtual nodes because, well, they're virtual. So we can see that I have the one node here. And if I click on this, and I won't just do the fact that my PC seems to be running slow here, this will take me to the compute service, which is the VM that all the Kubernetes components are installed on. Okay, so now let's get into the application itself, now that we see how to create virtual pools and manage pools. So my application here is relatively straightforward. I'm not going to show you the code I'm going to show you the Kubernetes manifests and how they look. So this is my deployment. My chatbot is going to be deployed as a Kubernetes deployment with one replica here. And notably, you'll see I have this node selector here. So I want to only schedule my deployment on my virtual node. So here I'm telling it to select this node in which the node type is virtual. So what you can do and what I would recommend, we do have out of the box labels for these, but they're kind of verbose. So what I would do is I would just label my nodes using kubectl label. So first, what I'm going to do is run kubectl get nodes and check to see what nodes are in my cluster. Okay, so I ran kubectl get node and I can see I have two nodes, which is consistent with what I showed you in the console. 110.02.100 with the role node. If it just says node, it means it's a managed node. Then I also have a second one called 10.02.128, which has the role virtual node, which indicates, well, it's a virtual node. So what I would do is label this node with this key value. kubectl label 10.02.128 node type equals virtual. This just makes it easier for me to indicate that this is indeed a virtual node. Anyways, while that's running, I'm going to show you the rest of the manifest here. So I have my custom application. This is my registry for it. I'm exposing it on two ports, 8080 and 8501, which is 8080 is the front end itself. 8501 is the metrics endpoint for the application, which Prometheus is scraping. And then I have my database credentials. Now, typically you would use secrets here. In my case, I'm just using a config map, but I have my Oracle credentials, my user, my password, and the connection string for my database. And then I have some resource requests. Now, this is important because keep in mind with virtual nodes, you only pay for what you're telling the pod to use. So it's very important for you to explicitly mention these requests and limits here because that's how much you're actually billed for, is how much you're telling the pod to use. Lastly, I have a basic service here, which is exposing my application front end. I'm exposing it as a load balancer. So when I spin this up, you'll see the load balancer provision in OCI. And then lastly, I have a service, which is just my chatbot metrics. Nothing too interesting there. So what I'm going to do is I'm going to apply this. Oh, and I'm that command failed, but it's fine. I already have it labeled anyways. So I'm going to let this run. This is going to deploy both my chatbot and the load balancer to front end that chatbot. So we can see the deployment travel chatbot has been created, the service has been created, and I can run kubectl get deployment travel chatbot to see if it's been deployed. And then I'll check to see if the load balancer has been provisioned. Okay, so we see the travel chatbot. It was not ready here, but now it is ready. And then I'm going to run kubectl get service travel chatbot, which is the name of the service that's exposing the chatbot. And we can see that it has an external IP. This is the IP of the load balancer that's front-ending it. So what I'm just going to do is I'm going to copy that and here. So we can see that we have our chatbot here. And I'm just going to ask it a question. Let's say hello. And you'll see I get an error here. So error contacting LLM. There's an issue with the host. It's because I haven't deployed my uh, LLM yet. So before we do that, I'm going to actually show you how to create a database using this operator, which will store my chat history. So like I mentioned before, I'm using the Oracle database operator, very useful tool if you want to provision databases and database schemas using Kubernetes. So here I have this manifest called single instance database create. This is just a simple single instance database. It spins up a container database. Nothing more complicated than that. It's not an ADB. It's not Exadata. It's just a very simple Oracle database. This also works with the free version of Oracle database if you're interested to test this out yourself. So here, the database operator creates a CRD called single instance database. And I'm giving it a name here. I'm just calling it SIDB sample default. And I'm giving this the service ID, Oracle 1. What edition of the database? Here it's enterprise. The secret, so my username and password for my database, dbadmin secret. The character set, the name of the PDB, what image it's pulling from, and so on. We do have a container registry with Oracle database container images if you're interested. This is the important part here at the bottom. We have this persistence block. This allows me to spin up a persistent volume. This persistent volume is going to be what will persists all of my database tables and so on. So here I'm telling it, let's make it 100 gigabytes, and let's use this storage class. OCI-BV is just short for OCI block volume. I'm telling it, let's spin up a block volume for this database. And then I'm giving it the access mode read write once, so only one pod can mount to that file block storage. I'm telling it one replica. I only want one database running on this node. And then node selector. Notice I'm saying node type managed. So here, what I would do is I would label my node. Actually, let me on kubectl get node. I would label this node type equals managed. And then now when I'm deploying this database, it will deploy to my managed node rather than my virtual node. All right. So actually already deployed this. The database takes around 10 or so minutes to deploy and actually be ready. So I already deployed this prior to this presentation, so I'm not going to run this. But if I just ran kubectl apply on this manifest, it would deploy my database. So I can actually query this using Kubernetes, using kubectl get single instance database. And we'll see that I have my database running, SIDB sample, using Enterprise Edition. This is the connect string and so on. So my database is up and running. My front end is up and running. Now I need to deploy the back end, or rather, sorry, the LLM. So deploying Olama is fortunately very simple. They provide Docker images that you can use. and it exposes a nice REST API for you to access the LLM. So very, very straightforward. So I won't spend too long on this, but my Ollama deployment looks like the following. So I'm calling it Ollama. If I go down to node selector, I'm explicitly telling it to use my manage node here. And then I'm using the Ollama container image here. I'm running this command to initialize here. It's the Orca Mini LLM. And then I'm exposing it on this port. Lastly, I'm exposing it as a service so that my front end can access Ollama and ask it questions. So very simple. I'm going to go ahead and run this. This will take around, I think, a minute or two to actually spin up. So if I run git deployment Ollama, I can check to see when the Ollama pods will be up and running. So this will take a couple of seconds. While we're waiting on this, I can actually show you the load balancer that's now front-ending my chatbot. Yep, so this is the load balancer. If I click into the load balancer, we can actually see the the pods as the backends to these load balancers. So that is where the traffic is going. It hits the load balancer and then goes to the pod to the pods on the backends. Yep. So if I click backend sets here, I can see my backend here, which has number of backends, one, which means there's one pod that has been spun up here. Click backends here. Yep. So this is my uh, backend. Now let's go back to Ollama. Okay, Ollama is up and running. So let's go ahead and go back to the front end that I had, and let's hope it works. So I'm going to first start off by saying hello. Okay, so it looks like it's contacting the AI. And there we go. So it gives me a response. I say, hello, hello, how may I assist you today? Maybe I can say, I want a list of tropical places, something that I would like to go to right now since it's very cold. And it might take some time. I'm not giving Ollama many resources here, so it might take some time for Ollama to actually give me a response here. But ultimately, what we're seeing is my front end is now communicating with Ollama, and the chat history is being saved in Oracle database. So if I refresh this page, I'll still see the chat history here because it fetches it. Okay, so this is cool. I mean, you could do this all in managed nodes. So where does the benefit come in with virtual nodes? So one of the benefits is that we can scale up a greater number of pods than usual. So by default in Kubernetes, you can deploy 110 pods per node, but virtual nodes does not have that restriction here. So let me demonstrate that. So I'm using the horizontal pod autoscaler. So I'm going to generate some um, test load to scale up to a large number of pods. In this case, I'm going to see if I can hit 150 pods instead of, the maximum was typically 110. So what I'm going to do is I'm going to apply this manifest here. This is my horizontal pod autoscaler. And I'm going to actually set the average utilization to something very low because I want to see it scale. So on average, I want an average utilization of 10% of the CPU um, across all of my chatbot pods. All right. Next thing I'm going to do is I'm going to start a new window here, and I'm going to generate some load to prompt it to scale. All right, so it's generating HTTP requests. What I'm going to do, and what I haven't shown yet, is my Grafana dashboard. So I have Grafana deployed in Prometheus, and I'm going to view the pods scale up in Grafana. While that's actually happening, I'm going to pivot a little bit to the Oracle dashboard. This is another good reason to um, use something like our database operator or our uh, database exporter for metrics, is you can actually view your database um, metrics within Grafana. So we do have a exporter here. So this is just another screen for us to monitor our database running in Kubernetes. We can see various metrics here, such as the status, the type of database, the commits, executes, and so on. Not as interested in this one. I would like to check the chatbot now. So these are my custom metrics coming from my chatbot, and I can see if I set this to the last 5 minutes, I can see various metrics that I'm exporting here, such as the number of pods, the LLM calls per minute, the CPU usage of Olama, and the CPU usage of the pods. And you'll see it's a little bit spiky, but this isn't much CPU usage anyways. Let me go back to here and let me check to see what my travel chatbot is looking like in terms of the number of pods. So we're seeing 5 here. It's not scaling up, so I wonder if there's not enough load. Check my load generation script. All right, so it did scale up to 5 replicas, but the CPU usage is still pretty low. I think the difference is the IP address might not be the right one. Let me double check this. No, that is right. Okay, let me set the average utilization even lower, just so I can brute force it to scale. And then I'll probably leave it at that. I know we are running a little bit low on time here, so I will. This is the last thing I wanted to show anyways. Let me go back to the dashboard here. Okay, so it is scaling up a little bit more. Number of pods, 7. 7 indicates the number of chatbot pods I have running, by the way. I'm not calling any Olama, or I'm not calling Olama since I'm not talking to the chatbot yet. So you're going to see pretty low usage there, as well as LLM calls per minute. Let me go back here. kubectl get HPA. Check to see how it's scaling. Okay, so it's going to take some time for it to scale up, but we can see that the number of replicas is increasing. Let me do this. Yep, so we can see it's scaled up to 16 now, but only 7 already. So it's taking some time for this to scale up, and it will take a little bit more time for all of these to spin up. But this can go up to 500 pods per virtual node. So this has much more room to grow in terms of running into restrictions there. So that being said, I'll just let this run. And in the meantime, let me just tell you a little bit about why this matters. So we're back at the demo architecture here. So what I showed you was the travel chatbot UI, talking to Olama, talking to the database storing information on block storage, and the Grafana dashboards, as well as the metrics. So what's interesting about this And what you can do now with this new feature where you can combine virtual and managed nodes is in the past, you would have to have multiple managed nodes here rather than having a combination of the two. So, sure, you could scale on managed nodes, absolutely. But if you wanted to scale past a certain number of pods, then you would have to spin up additional nodes, which then brings up the question of how do I scale up the nodes? Um, there you need to bring in something like the Kubernetes cluster autoscaler, which is great in its own right, but that does bring another level of management into your cluster where you now need to manage another autoscaler to scale up the nodes. With the virtual nodes, all you have to worry about are the pods themselves. That's it. All right. So that pretty much concludes my demo here. Um, Before we go, I would like to talk to you a little bit about the Virtual Code Innovate program. You might have heard of this before if you've seen one of my other cloud coachings. Just to give you a brief rundown of what we do is we give hands-on introductions to cloud services. So something similar to what you saw today, you can work with us and we can have a tailored session just for you. So, what is our Code Innovate program? So, ultimately, it is a 5 half-day online event to jumpstart cloud development. We work for an entire week, 4 hours a day, to build a prototype of your choosing. So, maybe it could be something similar to what we showed today. Ultimately, what we see here is that it facilitates rapid knowledge sharing. So instead of, uh, you know, reading documentation, you actually work hands-on with Oracle engineers like myself and Payal to actually build out prototypes for your use cases. So it's not just tailored demos. It's not just sample data similar to what we showed today. It's using actual data. And lastly, this is a great opportunity to showcase, your work to executive sponsors. Prior to the event, we have structured learnings. This is just some standard demonstrations and workshops, which is really just to give you a baseline awareness of technical solutions. The first day, we do ideation. So, what do we want to accomplish throughout the week? We assign tasks. We assign those tasks to people. We go off into groups, and we actually work on the use case. So we get the ideas from you all, and we start developing those tasks. We typically like to use project management boards like GitHub has to create these tasks. And then we just get to work. This is my favorite part. This is the bulk of the week is co-development, where we just, put pen to paper, work on your use case, whatever that may be. After every day, we check in. What do we need to accomplish for that day? What did we accomplish the previous day? And then we just get back to work. So we work throughout the week on the use case. And then on the last day, we present what we've worked on throughout that week. So this is called our lightning talk, very brief presentation where we show what worked, what didn't work, what we liked, what we didn't like, and what we accomplished throughout that week. The only thing we ask are some basic requirements. It is a free service, but we do ask for at least 4 developers from your side that are willing to spend 20 hours with us for that week, 5 days a week. Um, and of course, your use cases as well. So feel free to contact us using the email below. Uh, and we'd love to hear from you and your use cases.
All right, we are on the hour. So I just wanted to say big thank you again for everyone that tuned in today, and we hope to see you at our next event. Thank you all.
Thank you all.
Thanks, everyone.